Hello, my name is Hideo Nagahashi, and today I want to talk about exponential functions. So let me start. So let's look at the situation. Let's say currently the price of some merchandise is just $5. Then next year, suppose this one is changed to $10. Okay. So now, well, of course, from this, so we don't have enough information to predict the future, but at least there are two natural ways to build this. So the one way to build this is you can simply say that the price just went up $5 every year. Also, you can build this as the price doubled. Okay. Okay. So just following these two ideas, so let me predict the future. So for the number one, so let's say the T is a year, and then P is a price. See there? Let's just see what happens in the future. Okay? So I just say price $5, this is current. So that corresponds to the T is equal to 0. Okay? So when time is 0, so price is 5. And then the next year, so price is just went up to 10. So here it's 10 here. Okay? Now the first way, so I build this is just price goes up $5 every year. So that's why it's, let's assume that this just trend just keeps in the future. So I have just price plus 5, plus 1, plus 5, and plus 5 for each year. Okay? So in other words, so these the value. So this is 10 plus 5, 15 plus 5 is 20 plus 5. So I have 25. Okay? And then this is actually your old friend called linear function. If you graph this, T and P, the initial value, so that's the P-intercept. Okay? And then this number, so this is the increment for the per year, is called slope of this linear function here. Okay? And so in fact, you have a graph like this. The graph is just straight line. Okay? 1 corresponds to 10, 2 corresponds to 15, and so on. Yeah. Okay? Then what is the formula? So formula linear function is P is equal to, in general, this is A plus the BT. Okay? Then this A is your initial. So this is 5. Okay? P-intercept. Right? Then this B, this case is happen to be same number, it's 5. So actually your formula is expressed by P is equal to 5 plus 5T. Okay? Now let's look at the second point of view, which is really the theme of today. So now this leads us to the new concept called the exponential function. So let me draw the table for the second point of view. Okay. So this time I have the same table for these two. Okay. So T and P So 0, the initial is $5, then next year it's $10. So it's still same, but now you view this change in a different way. So you view this one as double. Okay? So then let's assume, so this trend now continue in the future. In other words, now I assume now this price doubles every year. Like this. Okay? So then you obviously have different table from the number 1. So 5 times 2 is 10, but now 10 times 2, which is 20, times 2, which is 40, times 2, which is 80. Okay? So linear function has this formula. So now what is a new formula this time? So for example, let's look at P1. So t equals to 1. So you get 10 by 5 times 2. How about P2? So that's 20 you get by 10 times 2. But starting from the initial value 5, so you see that 20 is obtained by 5 times 2 times 2. Okay? So that's 20. Okay? Then continuing this way. So now you will see that the P3, okay, the value at the 3 years later. So that's obtained by 5 times so you have to multiply 2 3 times. Then you get 40. P4 finally 5 times, you have to multiply 2 4 times. Then you get 80. Okay? And of course, instead of writing this, so usually we write using the exponent. Right? Okay? So in general, guess the formula. Pt, okay? P is equal to, sometimes the precisely, so sometimes you skip, you omit the t, but sometimes I really want to specify what's the input value. So P of t, so that's obtained by, in general, 5 times 2 raised to, remember this is 2 raised to 3, 2 raised to 4. So in general, so you can guess the formula of the price in this perspective. And then this is the instance of what is called exponential function. Okay? In general, exponential function is defined to be y is equal to a times b raised to x. Okay? Then this a is called, this is called initial value. Because if you plug in x equal to 0, y 0, a times x raised to 0, b raised to 0, which is a times 1, which is a. So, like this case is initial value is 5, right? The price is $5, okay? Currently. Then this b is called base. Okay? Just the one little remark is this exponential function. Sometimes people get confused with the quadratic function. Okay? The exponential function, for example, y is equal to 2 raised to x, the very simple one, okay? Which you don't have that. Okay? So that's an example of exponential function. So what is a quadratic function? So that's y is equal to x raised to 2. Okay? So both just look the same, but you have to view the exponent as an input, and here you have to look at the base as an input. So that's the difference between the two functions. And the graph of these are very different. In fact, it's interesting to compare. Remember we earlier draw the linear function. Okay? So this is y, here's a p. P is equal to y plus 5t, but now the exponential function actually looks like this. It just grows very quickly. So that one is p is equal to 5 times 2 raised to t. Okay? So both just have same value for t is equal to 0 and 1, but then the later. So it makes a big difference. Okay? Thank you.